live from Earth. It's Space Radio. I'm Paul Sutter, astrophysicist at Stony Brook University and the Flatiron Institute. And for the next half hour, your agent to the stars. We got an amazing, exciting, fun, and possibly thrilling show for you today, where we are talking about missing black holes. We're going to talk about black hole singularities. We're going to talk about black hole spins. We're going to, there's so many questions about black holes. The space cadets are black hole hungry today, and I'm going to feed them cheese. And also black holes. This show lives on listener questions. We record every Thursday at 8 p.m. Eastern here at Spaceman Studios in New York City. So leave a voicemail to get yourself on the air. You can also follow along with our space cadets tuning in live from around the world, including but not limited to the wonderful destinations of New Zealand, Christchurch, Accrington, UK. There are too many consonants in that word. Accrington, UK. We've got Chicago. We've got Howell, New Jersey. We've got Woomers, Australia. I'm not 100% sure that's a real place, but I'm going to take your word for it. Indiana, Austin, Texas, Canada, Pell City, Alabama, Portsmouth, England, London, Canada, the Virgo cluster. Now that is a real place, but I don't know, man. There's quite a bit of time delay between here and the Virgo cluster. What's the distance, the Virgo cluster? It's like 5 billion light years, something like that. It's far. It's far away. It's a close cluster, but it's still really far away. And I don't think you're tuning in live. I think you're watching the show from 50 million years ago. And also Ireland. All the space cadets tuning in live. If you want to tune in live and join them, that's every Thursday at 8 p.m. Eastern. Go to spaceradioshow.com for the live stream links, both on YouTube, Twitch, and Facebook, and show archives, all the good stuff. And then there's like a magic button that you can use to talk to me. Well, it's not really talk to me. You record a message and I play it on the show and I listen to it and then we answer the question on the show. But that's generally how it works, which is kind of like a conversation. It's a conversation where I do 90% of the talking, which is, if you know me, that's probably like most conversations. Now, Let's get to some news, because there's been some cool stuff. Of course, everyone's talking about the Starship, the SpaceX Starship test. It hopped up and then it landed, but it was on fire while it was landing, and then they tried to put it out, and then it blew up. So, yeah, that kind of is a success. It's up to you. It's debatable. I mean, it landed, and if you were in the Starship, you could have gotten out of the Starship, which that qualifies, right? That'd be a success as long as you're still living. And then it blew up. So they've got some work to do on their Starship. I still think that name is dorky because it's not going to the stars. It's going to planets. But I guess planet ship just does not have that same ring to it, does it, folks? It's like the planet ship. No, of course it's Starship. But what's wrong with spaceship? It's definitely going, not yet it's going to space, but eventually it's going to go to space. And so call it spaceship. Why do they call it Starship? I don't know. It's not going to this. Never mind. Oh, thank you, Nancy. Distance from Earth to Virgo cluster is 65.23 million light years away. I was off by 3 orders of magnitude. What's astronomy? It's close enough. I was right enough for government work and for astronomy. But I did want to mention this cool story that I've been following for a little bit because it's just so funny and fun. Astronomers have lost a black hole. Yes, space boat. Bob LeBlanc, one of the space cadets. Let's call it the space boat. Planet Express. I like Planet. Oh, that's from Futurama. I love it. That would have been cheeky and fun and in the spirit of adventure. But okay, we'll go with Starship. So astronomers lost a black hole. So there's this cluster, Abell 2261, which I'm showing to the space cadets right now. And it's a gorgeous galaxy cluster. It's a huge galaxy cluster. There's like 1,000 galaxies. It's like 1 million light years across. It's like a really, really, really nice galaxy cluster. Now, we know that galaxies, in general, host supermassive black holes in their cores. And we know that the central galaxies of a galaxy cluster tend to be the biggest galaxy in the cluster. And we also know that the biggest galaxies tend to host the biggest black holes. So we've gone looking for the supermassive black hole that's sitting in the center of this galaxy, in the center of the cluster Abell 2261, and we can't find it. We can't find it. So we expect it to shine in X-rays, not the black hole itself, but all the stuff falling in should glow brightly in X-rays, and it's not. We've done repeated X-ray scans of the center of this cluster, and it's just, we got nothing. So that's pretty funny. And we're like, okay, so what happened? Well, one scenario is that instead of one black hole, that there used to be two black holes, and they merged together and in the process got kicked out of the center of the galaxy. Okay, so we can't find the black hole in the center. Maybe it's around the center, like in the neighborhood. It's in the next town over. Well, we looked there too, and there are some dense clumps of stars, but there's no black hole there either. Like, no matter where we look in or around the central galaxy, there's no sign of a black hole. So the best explanation that we have is that the black hole is there because giant galaxies should have giant black holes, but it's not actively feeding right now, and so material isn't falling in, and so it's not glowing in X-rays, and so we can't see it. That's the best explanation. That doesn't sit very well with me, because that's like just saying like, oh yeah, there's a black hole there, but it's quiet. That sounds scary. That sounds ominous. Like, how do you shut off a black hole? In this cluster, Abell 2261 is not all that far away from us, so it's not like this is some ancient remnant, galaxy and cluster that shut off millions of years. No, this is relatively recent. Sometime within the past 50 million years, this black hole shut off. How do you get a black hole to shut off that quickly? How do you get it to stop feeding? What is it doing? Where is it going when no one's looking? I don't know. Something smells fishy to me. I know space cadets are immediately going to start joking that it's aliens. Because if you can't explain something in astronomy, then you can always blame the aliens. But maybe alien extraterrestrial civilization blew up the black hole, or they moved it. They put a big rope around it and tugged it out of the galaxy for their own nefarious. Maybe they threw it at us. Maybe the black hole is headed right for us right now, and it's going to consume. Larry Beckham nailed it. Yeah, I don't know. Maybe aliens, maybe they ate the black hole. Maybe they eat black holes. I could go on and on. I'm actually, Space Cadets, I am writing a review of Avi Loeb's book, Extraterrestrial. It's for the science journal Inference, which is a very, very major all science, statistical science journal. They asked me to do a review of it, and I said, all right, I'll do it. So I'm going to read the thing, and I'm going to write my review. I suspect they already know what my review is going to be. And I suspect what I know, but I'm going to say, I do know that his book does make some good points about how inflexible science can be, and how it's very, very hard to go away from mainstream thought and opinion and carve your own research niche and just do something a little bit out of the box. Science is very risk averse as a field. This is something I wrote about in my own book, A Sickness in Science, that I wrote. I finished the book, by the way, a couple weeks ago. It's off with the editors now. It's off with my publisher, University of Toronto Press. It will be out this fall or spring. I don't have a publication date for it yet, probably because they got 92,000 of my words to sift through, and they're like, they could be an easy editing job, or I feel bad for every editor of mine who has to deal with my stream of consciousness rambling style of writing. So they may have to be like, Paul, we need a year to sort through this. Or they may be like, you know what's golden. We're just going to ship this out as soon as possible. I don't have a publication date yet. So there are things I agree with Dr. Loeb. There are things I agree with. And that's one of them, that science is very risk averse. But I'll save the rest because I don't want to turn this into another Dr. Loeb rant, because we've had enough of those recently. But the Space Cadets, lovely, lovely people that they are, have been sending me so many questions. Bring them on this show. You know what? I don't want to bring Dr. Loeb. Russell on the Space Cadets suggesting I bring Dr. Loeb on the show. I don't want to give him a platform. Like I'm told, like one part of me would be totally willing to debate him, but the other is his voice is already so amplified. He's on like giant podcast. He was on like Sean Carroll's podcast. He's on Joe Rogan's podcast. He's on like CBS Evening News. Like his voice is amplified enough. I don't need to give him a platform. I don't want to give him a platform. I would rather just write an academic critical review of his book for my professional colleagues, and then like do a rant on my podcast and YouTube channels. I did a very long video, by the way, talking about his work. It's on my YouTube channel. You could check it out. I think Nancy will pull up a link because she always does. On the case against, why Oumuamua is not an extraterrestrial artifact. And I don't need to give him any more voice. So thank you for Russell for the nice idea, but I'm going to pass on that. Now, speaking of space cadets, there are so many space cadet questions. You guys have been patiently sending me voicemails for weeks that I've been ignoring, either because I've had guests or I've been going on endless rants. And so I need to show you some love. And so let's go. We're just going to play one. Here we go.
Your article on antimatter, possibly on the scale of stars, got me wondering what happens when gravitationally when matter and antimatter collide. First of all, does antimatter act on matter gravitationally the same as real matter does, and vice versa? And if so, what happens when two large masses of antimatter and matter collide? Does the deformation of space-time that they've created just instantly vanish? And if so, what does that look like? Is it detectable somehow?
All right, super fun question. John, you referenced an article I recently wrote, I believe, for space.com, that I explored this hypothetical idea that there might be antimatter stars orbiting the Milky Way galaxy. And you're asking, like, what would happen to these stars? What do they do? What's their interaction? They do have the same gravitational interaction with regular matter. And as regular matter, they still respond to gravity. You can be gravitationally attracted to an antimatter star. You can have an antimatter star in orbit, or an antimatter planet in orbit around an antimatter star. It's totally fine. And when they touch, when a antimatter star and a regular star touch, they blow up and annihilate and release a tremendous amount of energy. These events would be very, very rare because space is large. Stars don't collide all that often, and if antimatter stars are very, very rare, we're not going to see them. But it might explain some of the properties of cosmic rays that we observe. We see some high-energy cosmic rays that we don't know exactly where they're coming from, and so we're throwing out some wild ideas. But the basic gist is there. Antimatter and matter respond to gravity exactly the same, or at least they do in the standard model of physics. We've tested this because if they operated differently in gravity, this would help us gain a better understanding of physics because it's not something we predict. But we tested it. It's totally the same. So moving on.
Hi, Dr. Paul. My question is, how do physicists deal with infinity?
Ooh, how do physicists deal with infinity? We don't. Physicists don't deal with infinity. We don't like infinity. When infinities show up in our math, that's our math telling us that we have the wrong tool for the job. When an infinity shows up, like the infinity at the center of a singularity, or the infinity at the Big Bang, like that's our physics saying, hey guys, listen. I know we have a great relationship. We've had a lot of fun together. We've gone on some crazy adventures, but if you want to go further, I'm not the one for you. All right. It's not you. It's me. This is a little bit beyond my comfort zone. This is just a little bit too much for me to handle. I can't give you an answer, and you keep asking the same questions to me, and I just can't give you the answers that you want. So I think it's time for us to part ways as friends before it gets acrimonious, before we start fighting. I'm going to tell you infinity because I am telling you it's time. It's time for us to break up. And you need to find someone else. You need to find some other theory of physics that can give you the answer you're looking for. I just anthropomorphized laws of physics in terms of relationships. Now, I've done a lot of bad metaphors. That was a pretty good one. Infinity is fake news. Infinity scoffs at physicists. So trickstery, it does. Now, space cadets, except in your bank account, if an infinity showed up in my bank account, I honestly would be very, very worried. Now, speaking of patient space cadets, there have been questions rolling in since even before the show started. We've got Russell, space cadet, does altering the spin of one of two quantum entangled particles break the entanglement, making quantum communications impossible? I get variations on this question all the time, because you have entangled particles, like you've got a spin up particle and a spin down particle. You prepare them in a very special state. Can you hear me rubbing my hands together? That's me preparing this very special quantum state. And then you can separate them. And then when you look at one of them and you're like, what state are you in? And it's state up. You're like, oh, cool. I know now, because you're state up, that your partner over here, even if it's on the other side of the universe, is in state down. So it feels like you can start doing some communication. Like, oh, if I start taking this and like flipping it down, up, 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 down, 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 up, up, I can do some like Morse code and make its partner on the other side of the universe flip up and down, up and down, up and down. And you can like talk to each other faster than the speed of light. So this doesn't work for exactly the reason that Russell pointed out, is this works on measurements, not manipulation. When I open up the box and I'm like, hey, particle, are you up or down? Oh, you're down. That's cool. That's all I know. If I start reaching into that particle and like twisting it, like I get out my screwdriver, I'm like, hey, particle, can you be up? That's it. I'm just monkeying around with that particle. There's no more entanglement with the other particle. So quantum entanglement is not used for communication. It's used for encrypting communication, because you can tell if someone's messed up with your signal, but you can't use the entanglement itself to communicate. So stop pretending you can. I'm sorry to break the dreams and of a bunch of YouTube videos and a bunch of YouTube watchers, like, can quantum entanglement make communication possible? Faster than light communication? No, it can't. Okay, just stop. All right. Rob Bowman on YouTube is asking, how likely is it, in my guesstimation, that gravity and particle physics can be united? Would it be a crisis for physics if they can't? That's a very interesting question. And this is a question that I've come off and on of over the course of years in terms of thinking about. We have this massive problem. We have gravity over here that we describe beautifully with general relativity. And then we have all the other forces of nature that we describe beautifully in its own ugly way with quantum mechanics. And when we try to mush them together so that we have a quantum mechanical description of gravity, everything blows up. We get all those infinities and nothing makes sense. And we've been working on it for decades with like string theory and loop quantum gravity and supersymmetry, and like nothing's working. Not just like, oh, we can't come up with cool ideas and someday we hope to test them. No, it's like we're doing experiments on these theories that are ruling them out. Like our best ideas that we've had for half a century are wrong. And so it makes you start to wonder, is this unification even possible? Are we clever enough? I feel like we might be barking up the wrong mathematical tree. I feel like the solution, I do believe that you can come up with or do hope, let's say that. I hope that you can come up with a unified description of gravity and quantum mechanics. We may not. Nature is under no obligation to have a quantum mechanical description of gravity. Like, we hope there is, because there are obviously regimes that this physical laws could, or understanding and theories could apply towards, like, say, the center of a black hole. Like, the center of a black hole is a real thing, but we don't have the physics to describe the center of a black hole. So we feel like we ought to, because, hey, if it exists in the universe, it exists in the physical universe, we should have a physical description of it, and we don't. So we feel like there's something there that we're missing, but I feel like what will be the unification, I just wonder if it'll look absolutely nothing like our current theories of physics. Like, almost unrecognizable. Like, the way quantum mechanics looks very, very different than classical mechanics. And general relativity looks very, very different than classical gravity. Or, like, Newtonian gravity. I feel like, string theory was an attempt. It turned out to be wrong. Looks like it's wrong. I feel like we need a brand new attempt. And thank you so much, Russell, for the super chat. Guys, this show is brought to you by you. It's your contributions that keep this show rolling. I swear, it really is. And so go to patreon.com/PMSutter. That's P as in Paul, M as in Matthew, Sutter as in Sutter is like butter, but with an S. And you can contribute, keep the show going. If you're watching live right now, you can drop a super chat in YouTube where you just contribute a little bit. And that really helps. Every little bit added together makes this show possible. I do want to give a shout out. I do have sponsors for my podcast, Ask a Spaceman. I want to thank the Great Courses Plus for sponsoring my podcast. And I want to give them an extra special mention because they've been really, really wonderful partners. They've been really working with me and my audience to find the right kind of courses that my audience would be interested in. So you can get 1 month free of the Great Courses if you go to thegreatcoursesplus.com/spaceman. That's me, Spaceman. Thegreatcoursesplus.com/spaceman. Go to that URL. You'll get 1 month free. They've got all sorts of, I'm a total history dork. I listen to history podcasts. I watch history TV shows. The history content on the Great Courses Plus is amazing. I'm watching a course on the history of food, and I'm not ashamed by that. And neither should you be. Utaran is asking, do you think God is an advanced alien? It depends on your definition of God. It depends on your definition of advanced. And it depends on your definition of alien. And that's as far as I'm going to go with that question. Larry is also asking about ergospheres. That's a word, isn't it? Can I pull up a picture of an ergosphere? Like, really, ergosphere. He's asking, does frame dragging have a type of friction? I heard that time becomes space and vice versa. How does that work? Ergosphere is, where's a good picture for us to look at? Here's something that kind of sort of works. Let me go over to screen share here. This is from physicscentral.com. Look at that picture. Look at that cartoon. So rotating black holes, that's what we're talking about. You've got a rotating black hole. You have the event horizon. This is the point of no return. If you cross the event horizon, you can't escape that one. That's what makes black holes black. But surrounding but only a rotating black hole is another region where space itself is being dragged around the rotating black hole. The image I like to have in my head is if you have a heavy coffee table in the middle of a big rug and you start spinning the coffee table, it can like bunch up the rug around it and then eventually start dragging the rug itself. So even though you're not touching the coffee table, you can still end up going in a circle you're just standing there because the rug underneath you is making you move. So the ergosphere, that's what it does. It's called frame dragging, which is a really cool term. Frame dragging pulls objects in a circle. You can't help but move. Like if you enter the region of the ergosphere, you will move in orbit around the black hole. You have no choice. Now you can still escape. You can still escape if you try really hard. But if you don't do anything, you will plunge through the event horizon and then you'll die. I hope that helps. Like that's the ergosphere. Pretty straight. I mean, there's way more complicated mathematics to go along with it. and a lot more cooler effects. Maybe I'll do like a podcast episode on the ergosphere. Sometimes I like saying ergosphere. Do ergospheres create gravitational waves? Viso2D is asking a follow-up over on YouTube. So if a black hole is perfectly spherically symmetric and it's spinning, it will not emit gravitational waves. But if it's lumpy or a material is falling in, then you can generate gravitational waves. But a perfectly symmetric, smooth object is spinning in space will not generate gravitational waves on its own. You gotta have a little bit of lumpiness to make that happen. Utaran is also asking about the James Webb Space Telescope, question mark. It did pass its final tests. Let's pull up a picture. James Webb. Maybe there's a job. Could I somehow have Nancy pull up pictures like remotely, even though we live hundreds of miles away from each other? Look at that James Webb Space Telescope. That'd be fun. But that's a discussion between me and Nancy, isn't it? Now, and if you're listening to the podcast version of it, it doesn't matter. James Webb Space Telescope, it finished its final tests, slated for launch in, was that October, November of this year. I was on the Weather Channel a couple weeks ago and they asked about the James Webb Space Telescope. And I said, every time a bell rings, the James Webb gets delayed by another month. Like, it seems like it's 16 years late, right? This telescope is 16 years late. That's a little bit late. I don't think I've been late on some very serious thing. I don't think I've been 16 years late on anything. Is it launching? Listen, it's not over until the fat rocket sings, okay? I am not going to celebrate the launch of James Webb until it's at L1, it is fully deployed with its mirror, and it has first light, and the images look good. When that happens, I'll drink to that, a nice carbonated beverage. Before that, like when it launches, a lot of people be clapping. I'm not clapping. I'm sweating. Speaking of not sweating at all, I have today's cheese. If NASA decided not to launch it, can I have it for my bedroom? I think it's a little bit larger than a bedroom. I'll mount it in my backyard. I'll do that. NASA, if you decide that JWST is just not going to launch, just call me. Listen, I do a cheese every week. Our cheese sponsor is Dom's Cheese, DOMScheese.com. They are wonderful. They are magnificent. They are good to me because they give me free cheese. And today's cheese is Tom St. George. Tom St. George. Now, it's like St. George and the Dragon. It's named after that. It has absolutely nothing to do with it. Except like in the legend of St. George, the villagers, to appease the dragon, would feed the dragon sheep. And then St. George was like, you know what? Instead of eating sheep, you're going to eat my sword. And he killed the dragon. So there's a town in France, Saint-Georges. And they're like, hey, we know this legend. We know this story. We got a bunch of sheep. We don't have a dragon, though. So what do we do with all this sheep? Maybe we should make a cheese. And everyone's like, you know what? I can get behind that idea. And so they did. And they made this wonderful, it's in the Pyrenees Mountains. Ooh, wow. Look at that. Lovely, moist and creamy, a very smooth texture. My tasting notes here say that the flavor grows gently on the palate and at first has notes of toasted wheat, followed by cream, leek, and chives. It is semi-firm and will delight all kinds of cheese lovers alike. I'm a cheese lover. I am prepared to be delighted. That is just pleasant. That is just dreamy and creamy I get the wheat in the chives and the leek. It's like my tongue is dancing in a field in the Pyrenees. And the sun is shining. And there's like also a baguette in my future. This is amazing. This is a wonderful cheese, Tom Saint-Georges. I could eat this all day long. I will eat it all night long. Space Cadets. Unfortunately, we are almost out of time. Once again, this show is brought to you by you. Go to patreon.com/PMSutter. Go to thegreatcoursesplus.com/spaceman for a free month. Drop a super chat if you feel like it. Thank you, Russell, for dropping that. You can go to my website, pmsutter.com/store, to buy autographed copies of my books or t-shirts and mugs that say if it's interesting, it's probably wrong. That's pretty funny. I'm getting this show because I'm going to eat more of this cheese. Thank you. Thank you, Nancy Graziano, for producing this show, Wrangling the Space Cadets. Catch the live stream every Thursday at 8 p.m. Eastern. Visit spaceradioshow.com for all the links. Of course, thank you, Space Cadets, for listening and for all the amazing questions. See you next week. And remember, science is for sharing.